There, and welcome to this practice set on slope-intercept form. Give this video a thumbs up if you find it helpful. Subscribe to the channel for more math help. And if you have a question about anything you see in this video or about something you'd like to see on the channel, please let me know in the comments. Without further ado, pause the video to work these problems on your own and then come back to check your work. So for problems 1 through 4, this was simply an exercise in identifying the slope and y-intercept. For the most part, this skill is mix and match, like you just got to match up the M's and the B's. But there are a couple of things that you might see that tend to trip up students, and I wanted to address those in the practice set. Looking at the first one is the most straightforward of the 4 problems. And if I were to write the form underneath it, hopefully you can see right off that the 3 and the M line up. Now, what sometimes throws students is right here. You have a minus sign in the original problem, but a plus sign when we talk about y-intercept form or slope-intercept form. So we have the mx plus b. Now, to reason your way around this, if you kind of tripped up on this, if you said that the y-intercept was 4, I want you to remember that subtraction can be written as adding the opposite. And so if I change that -4 to plus -4, what that does, I'm going to go over the plus sign with the black there, is that's going to line up your plus signs so that it becomes more obvious that your B value is not 4, but -4. So when we do see subtraction, we want to remember that that subtraction is like a negative that's attached to whatever comes after it. So in this case, my slope value is 3 and my B value is -4. Now, one of my colleagues that I work with, when her students are asked for the y-intercept, she will actually not accept B equals -4. She will ask her students to give the ordered pair, which is 0, -4. And that is on purpose to make sure that we're associating it with the coordinate plane and with the location where the x coordinate is 0 and the y coordinate is -4. Now, for my students, I would accept either. I do understand her reasoning for requiring that of her students. So it's one of those things, make sure that you know what your teacher is expecting of you. For the next problem here, we've got y equals -3/4 x. And if I line up my formula underneath it, you can see that the -3/4 does correspond to the slope there. So our slope is -3/4. That's our rise over run. But here, there's nothing there. Even if we like sneak in a plus sign, there's just simply nothing there. So what is the y-intercept here? To answer this, we go back to some of our basics way back when we did solving one-step equations. And I really emphasized the idea of opposites adding to 0, and then something plus 0 is just the something. And so you want to think to yourself, if I needed to add something here, what could I add after the -3/4 x that would leave it alone and would basically go away? And the answer to that is 0. If you had -3/4 x plus 0, that would just be -3/4 x, and you wouldn't have to write the plus 0. It's not wrong to write the plus 0. It is a plus 0 there, but it's also not necessary. And so our B value there is 0, or if you wanted to do what my colleague does, you would say the point 0, 0. In other words, this particular line goes through the origin. Now we have something similar going on here. Okay, so in this one, you might see fairly quickly that the B value is a 3. And what I get a lot with my students is when they're asked the slope here is I'll get x. The slope is x. Well, it can't be x. The x is lining up with the x here, and we know that the slope is the number multiplying the x, okay? And so we've got a number right there that we're looking for. Okay, and so we want to think the same way about it. What number could I multiply x by that would give me the x back, or just leave me with the x? And the answer to that is 1. And so we've got 1x, because 1 times x would just be x. And so in this case, our slope is 1. Now, in this last example, this is playing off a misconception, or one of those like kind of careless things that students sometimes don't pay attention to. And that's this: when we write slope intercept form, we almost always put the mx on the left and we put the b on the right. And by that, I just mean to each other, not relative to the equal sign. And we just do that all the time. Not 100% of the time, but a lot. And there's no rule, though, that says that every time you look at y equals something that it has to be mx plus b. So in this case, it's actually written as b plus mx. So it's like the order has been switched. The way we want to go about reasoning through this, though, is we want to remember what I said a moment ago about the subtraction being adding a negative. So instead of thinking about this as 4 minus 3x, I am going to write it as 4 plus negative 3x. And the reason I want to do that is because adding is commutative. A plus B is equal to B plus A. Subtraction is not commutative. So if I want to go and rewrite this and switch the order, so instead of y equals b plus mx, I've got it in the order that I'm more comfortable with, I need to be able to switch it, which I can do with adding and not with subtracting. So 4 plus negative 3x would become negative 3x plus 4. And I guess the shorthand way of thinking of that is when you see a subtraction sign, you want to remember that that subtraction sign is attached to whatever comes after it as a negative sign, okay, because of that plus negative. Now, once I do that, then it becomes more apparent that our m value here is the negative 3, and the b value here is the 4. Okay, so that's that. Now, again, for the most part, this is just what I sometimes call mix and match, where you got to match up the M's and the B's. But there are a couple of these little subtle things, especially the first time you see them. So if you are brand new at doing slope and y-intercepts and you haven't seen these things before, we need to think our way through them and talk our way through them. And then once you know it, it'll get stuck in your brain and you won't really think about it much afterwards. These next 3 problems are asking you to write it in slope intercept form, and just want to emphasize here the vocabulary, because you will get directions like that, write it in slope intercept form, and you need to know that that means y equals mx plus b. Okay, like that you need to know. So let's kind of work our way through this. So we want to get this to y equals. And so if I look at what I got going on with the y, it's being multiplied by a 3, and I have this positive 2x that is being added there. And so I'm going to move my 2x out of there by subtracting 2x from both sides. So 2x minus 2x is 0, and that is why it cancels out, leaving me with 3y equals 9 minus 2x. And then we will divide by 3. If I divide everything on the left by 3, I must divide everything on the right by 3. 9 divided by 3 is 3. And then I'm going to rewrite that as minus 2/3 x. Okay, so I'm basically going to yank the x out of the numerator there. And last thing I want to do here is remember that subtracting is plus a negative. And so I probably want to rewrite that in the mx plus b form. So we'll move the negative along with the 2/3 x. Okay, and so your answer should be y equals negative 2/3 x plus 3. You could put the negative out front if you want. Okay, that's kind of up to you where you want to put that. All right, next one. In the next one, we've got a negative 3x that's being added onto the 4y. And again, we're trying to isolate the y. So we're going to need to undo the multiplication, but we're going to take care of this first. So I'll add 3x to both sides. And again, the reason we're doing that is because negative 3x plus 3x is 0, and 0 plus 4y is 4y. That's the y behind why it cancels. 8 plus 3x is the same as 3x plus 8. And then we'll undo the multiplication with division. Okay, I had to pause the video for a second there because I inhaled a peanut. And we just did the whole works with the coughing and the sneezing, and now my eyes are watering, which is awesome during a video. Hopefully I won't have to pause again. 4 divided by 4 is 1, and 1y is just y. So that's why the 4's cancel out. And I'm going to do the same thing here. I'm going to pull that x out of the fraction to get 3/4 x. And then 8 divided by 4 is 2. So we get that in y equals mx plus b form. You will sometimes see when you're asked to do this, you'll end up with a fraction over here. When I wrote these problems, I wrote them so that the y-intercept came out something nice, but that is not a guaranteed thing that it would always come out nice. This one is similar, it's just in a different form. So we have the constant is moved over to the left side of the equal sign. And you can do this in one step. You can do this in a couple steps. When I did it out on my own, I did this all in one step. I'm going to go ahead and add 7 to both sides because negative 7 plus 7 is 0. Again, y it cancels out. And then we have on the other side there 0 plus 7 is 7. And now it's similar to the one we had over here where we've got that 2x being added on. We don't want it added on. And so we will subtract it from both sides. And this is where experience comes in handy. We've got the 2x minus 2x is 0. So we're left with the y. What I did over here is I ended up with 9 minus 2x, and then I divided, and ultimately I ended up having to switch the order. So what I'm going to do here is switch the order at the outset. Instead of 7 minus 2x or 7 plus negative 2x, I'm going to write negative 2x plus 7 and go straight to that. If you aren't sure what I did there, okay, and this is where I always want my own students to ask questions if I do something like that, and I have a student that honestly just doesn't quite follow what I did. So we were subtracting the 2x from both sides. Remember that subtracting is adding a negative. And then once I have it in adding form, 7 plus negative 2x is the same as negative 2x plus 7. So when you're in class, always ask if your teacher does something like that. Just say, can you go over one more time why you were able to switch the order? And try to be specific when you're asking a question. Don't say, I don't get it. That isn't helpful. You want to say, okay, I got up to where you were subtracting the 2x, but what I don't understand is why the negative 2x ended up in front instead of 7 minus 2x. So you really want to explain, this is the step, this is what I thought it was going to be, and you wrote something else. Okay, and hopefully your teacher can do a quick little explanation like that. And for the last 3, these are just to graph what we got in problems 5 through 7. So using our quick graphs, using the slope and y-intercept, looking at this first one, I have a y-intercept of 3. And remember, that does mean the point 0, 3. And so I get that first point by just looking for the y-intercept. And now I have the slope. So its rise is negative 2. That's my rise over my run, which is 3. So starting at the y-intercept, okay, not at the origin. I've seen that a lot where students count at the origin. Starting at the y-intercept, from here, we're going to go down 2 and right 1, 2, 3, and that should give us our other point. So 1, 2, 3. And that's all we needed to get the line, and I will do my best to connect these. And remember, when you're doing your lines, try to make them go to the edges of whatever coordinate plane you have, and make sure you have arrows on either end. For the next one, our y-intercept is 2, also known as the point, not that point. Don't write that down. Let's try that again. The point 0, 2. And so I'll put my dot here at the 0, 2. And my slope now is 3/4. So my rise is 3, my run is 4. So starting at my y-intercept, I'm going to count up 1, 2, 3, and over 1, 2, 3, 4. And find me another point. 1, 2, 3, 1, 2, 3, 4. Okay. Hopefully I counted right the second time. Something like that. There we go. And last but not least, we have a y-intercept of 7. So that's the point 0, 7. So going up here to the 7. And now this slope is -2. You want to remember it's -2 over 1. And so we have a rise of -2 and a run of 3. So starting at a run of 3, run of 1. I don't even know why I said 3. Okay. So starting here, we count down 2 and right 1. So down 2, right 1, and that gives us the other point. Now, if it's very, very important to you or your teacher that you have a very straight line, what you would do from here is you would count down 2, right 1, down 2, right 1, and see how my line kind of drifted there. You could make sure that you have a much, much, much nicer line if you keep counting the points. So, there we go. We'll erase that messier one. So we have the line a little bit better done. If you're freehanding it, it's going to drift a little bit. Usually that doesn't matter. Usually it's not. When I'm grading my student work on this, I look for 2 points that are accurately plotted, not for whether or not the line actually drifts across the page at all. If you need it to be accurate, you would use what we call a graphing utility or a graphing calculator. All right, so don't forget to like and subscribe, and let me know what you think by commenting below. I will see you in the next video.